Hi, this is Ling from 3D Science Modeling. I'm a science educator and a researcher. I use computer models to help students learn science. Many students heard about Thomas Morgan's experiments when learning about sex linkage. Can they gather data to identify the relevant inheritance patterns by themselves? Beyond that, can they gather data to distinguish the patterns caused by a sex-linked gene and a non-sex-linked gene? Thomas Morgan's experiments on white-eyed fruit flies connect the inheritance of a trait to a sex chromosome. Today, I will introduce an activity in which students gather data from a computer model to identify how the inheritance patterns differ between a sex-linked trait, white-eyed color, and a non-sex-linked trait, vestigial wing shape. This activity represents the engagement and exploration phases in the 5E learning process. It also implements an effective teaching practice, identifying similarities and differences. In class, we introduce students to fruit flies, which are a type of model organism in biological studies. We may tell the story about how Morgan found a single white-eyed male fruit fly and crossed it with a female fruit fly with normal red eyes. After a few generations, Morgan found white eyes were inherited differently between male and female flies. When students become curious about the differences, we may invite them to use a computer model to find out. We clarify to students that to help us see the differences, today we will gather data on two traits separately, white eye color and vestigial wing shape. Then we will compare their inheritance patterns in male and female flies. We will introduce how to identify males and females. The male's abdomen tip is much darker than the female's, and the male fruit flies are smaller than the female flies. Next, we plan the investigations. We let students discuss how many types of crosses they should conduct to gather sufficient data to answer two guiding questions for each trait. Is a trait dominant or recessive? Is a trait inherited differently between male and female flies? After combining the traits and the gender, we can see that 4 types of crosses are needed. We will have at least 5 trials for every cross. Now let's gather data. Access the model using the link in the description. First, choose case 1 to investigate the white eye color inheritance. A brief introduction is provided at the top. You will choose a male and a female fly for every cross. When we get the next generation, we can sort them. You always see the females at the left. The monitors below provide the numerical data. Case 2 allows students to investigate the wing shape inheritance. You can operate it in the same way as you do in case 1. When reading the numerical data, we always remind students to check the monitors carefully so they do not miss any data points. We start with crossing 2 red-eyed flies. In this trial, we get 30 red-eyed females, 16 red-eyed males, and 14 white-eyed males. There are no white-eyed females. Record data. In the second trial, we only get red-eyed flies. Half of them are males and half of them are females. In the third trial, we get 32 red-eyed females, 15 red-eyed males, and 17 white-eyed males. Record data. We will continue this process until completing the data collection. Now we finish the data collection for case 1. Let's analyze the data to identify patterns. You can have your students use a calculator. Here, I use the Google Sheets formulas to calculate the subtotals and the ratios. Crossing 2 red-eyed fruit flies may generate 2 types of data patterns, and we will calculate them separately. Here, I use the Google Sheets formulas to calculate the subtotal for the first type of pattern. I get 118 red-eyed females, 59 red-eyed males, and 59 white-eyed males. And then, to calculate the ratio, we get this 2 to 1 to 1 ratio. In the same way, I'm going to calculate all the subtotals and the ratios here. Then we gather data on the vestigial wing trait. We start with crossing 2 long-winged flies for 5 trials. If it is hard for you to find the vestigial winged flies, you may first sort the flies and then choose the male and female. After gathering the data, we analyze the data to identify patterns. Again, here I use the Google Sheets formulas to calculate the subtotals and the ratios. Now we may compare the inheritance patterns of the 2 traits. In case 1, when we cross 2 red-eyed flies, we either only get red-eyed flies or a 3 to 1 ratio of red-eyed and white-eyed flies. In the previous video, we have figured out that these types of patterns suggest that the red-eyed trait is dominant over the white-eyed trait. When we only get the red-eyed flies, the ratio of males and females in offspring is 1 to 1. But if we get white-eyed flies, all white-eyed flies are male. This is the evidence that the white-eyed trait is inherited differently between males and females. Looking at the cross of 2 white-eyed flies, we only get white-eyed offspring. This is consistent with the idea that white-eyed trait is recessive. In class, you may check the whole class data to help students see that this is the only pattern resulting from this type of cross. Then, when crossing a red-eyed female with the white-eyed male, we either only get red-eyed flies, or half of them are red-eyed and half of them are white-eyed. In this type of cross, the ratio of males and females appear to be 1 to 1. Last, when crossing a white-eyed female with a red-eyed male, all of the female offspring flies are red-eyed, and all of the male offspring flies are white-eyed. Again, this pattern clearly shows that the white-eyed trait is inherited differently between males and females. In case 2, we can see crossing 2 long-winged flies generates 2 patterns: 100% of long-winged or a 3 to 1 ratio of long-winged and vestigial winged, suggesting that vestigial wing trait is recessive. In case 2, we can also see that when crossing a long-winged fly with the vestigial winged fly, swapping gender does not alter the inheritance patterns. The proportions of males and females displaying a vestigial winged trait are always the same. In other words, the vestigial winged trait is inherited in the same way in males and females. Now students see how the inheritance patterns differ between the white eye color and the vestigial wing shape. From there, we can introduce the idea of sex linkage to explain these differences. You can find the model link below in the description and try it in your classroom. Leave your comments. Thanks for watching.